Ever wondered what makes great software truly reliable? It's not just about developers writing code. It's about a crucial process called software testing. But effective testing isn't just about running random checks. It's a science guided by 7 fundamental principles. Let's break them down. First up, Principle 1. Testing shows the presence of defects. This is a big one. No matter how many tests we run, we can never prove that software is 100% bug-free. Testing's job is to find bugs, not to guarantee perfection. So, if a test passes, it just means no defects were found in that specific scenario. It's all about reducing risk, not eliminating it entirely. This leads us to Principle 2. Exhaustive testing is impossible. Imagine a simple form with 10 fields, each with 5 possible options. To test every single combination, you'd need to run nearly 10 million tests. It's just not practical. Instead, we use smart techniques like risk-based testing to focus on the most critical areas where failures would be most impactful. That's why Principle 3, early testing, is so important. Finding a bug during the design phase is incredibly cheap to fix. But finding that same bug after the software has been released, that could cost 100 times more. By getting testers involved from the very beginning, in requirements and design reviews, we can prevent defects before a single line of code is even written. Next, we have Principle 4, defect clustering. This is the 80-20th rule in action. It means that about 80% of the problems are usually found in just 20% of the modules. Complex features, or areas that change a lot, are bug magnets. By identifying these hotspots, we can focus our testing efforts where they'll have the biggest impact. Now for a tricky one, Principle 5, the pesticide paradox. If you run the same tests over and over again, they'll eventually stop finding new bugs. Just like pests becoming resistant to pesticide, your software becomes immune to old tests. To avoid this, we have to constantly review, update, and add new test cases to keep our testing effective and uncover those sneaky, hidden bugs. Principle 6 tells us that testing is context-dependent. There's no one-size-fits-all strategy. How you test an e-commerce website, focusing on user experience and payments, is completely different from how you test an ATM system, where accuracy and security are everything. The context of the software dictates the entire testing approach. Finally, Principle 7, the absence of errors fallacy. This is a crucial reality check. You can have a piece of software that is technically 100% bug-free, but if it doesn't do what the user actually needs, it's useless. Imagine a payroll app that calculates everything perfectly, but uses outdated tax laws. It works, but it's wrong. Testing must validate that the software not only works correctly, but also solves the right problem for the user. So, how do you apply these in the real world? Start testing early, focus on higher-risk areas, constantly update your tests, and always remember the user's needs. By applying these 7 principles, we move from just finding bugs to building truly great, reliable, and valuable software. Thanks for watching. If you found this helpful, don't forget to like, subscribe, and hit that notification bell for more insights into the world of tech. See you in the next video.